the airport, and that was because my wife was taking light rail. Or she was someplace, and I just parked her car at that lot so she could pick enough food.
Okay.
Hey, we got an official person. So.
Official, yeah. Officially, so it feels like we're just gathering together. I think that several of us are hung up in traffic as well. So thank you for coming, and we have a wonderful presentation tonight by Matt Griscom. He is the author of this book, MetaAutomation, and these are going to be available this evening if you're interested after the talk. And we also have one available as the door prize. So welcome. I'll leave it to you, Matt, for your own credentials. And thank you for coming and thank you for being part of this.
Thank you. Okay. So I'm Matt Griscom, and I was telling Joe earlier, it took about a year, depending on how you count, it took about a year and to create MetaAutomation and write the book. So I was doing other things too, and now I'm on the board of advisors of an Oregon corporation called Ugamoto. But that's some synchrony there, and I'll bring that up in the slides. But that's basically what I've been doing. And I think the low turnout as well might be bad traffic, but I was thinking that maybe it's because, and I've had this reaction before, people are wondering, what is this MetaAutomation? And what is it all about? It's not a tool that you can buy. It's not an additive technique, and it's not an incremental thing. It's kind of radically different. And so it's a little hard to relate to. So I'm going to ask a favor of you guys, the audience, to please let me know if I say something that's confusing. You're not the only one. So raise your hand or speak out or let me know. Can I clarify that, please? Otherwise, it's way too much information in the book for me to present. I think the slides I can get to in an hour. But otherwise, the whole topic is way too much information. So please do ask me if there's something I can clarify. I've been adjusting my presentation towards what I think is most important to you guys. And I'm still changing things around a little bit. So before I dive into the meat of the stuff, I wanted to show you, basically, yeah, this is my book, MetaAutomation, and it's a pattern language. And just so make sure you know, well, what is a pattern language? Anybody seen this book before? X-unit test patterns? How many people know about this book? Really? Okay, I'm surprised. Well, this is a book that is the closest analog to my book. It was written by Gerard Mazzaros, and I reference it heavily, but all it is a set of patterns of the ways that people have done things in the test pattern. So it's a book full of design patterns. And so what he does is a great job of cartography. He just gives them names and he puts them in categories and relates them to each other. Otherwise, I don't think the book is very great, because most of the patterns of this book I would not recommend following, actually. Things like chained tests, he describes it nicely, but I wouldn't recommend doing it that way. But that's probably the closest analog. So MetaAutomation is not a tool. It's a pattern language, which means there are 5 design patterns, and I'll have a diagram later in the talk, that relate to each other in a ordered dependency, which is what makes it a language and not just a set of design patterns. So I say a pattern language, more like what Alexander wrote, the architect who inspired the software design patterns. And the architect Alexander wrote about patterns of architecture. And so my book is more like his in that respect, although he had 2 chapters, I think I have 5. But it's really a way of doing things. So imagine you come into work in the morning and you discover there's some email, the build broke last night, and your automated test failed. And well, you have an exception, HTML control not found exception, and fail in big red letters. Your test failed, and that's all you have to go on, HTML control not found exception. And here comes your lead. Well, I noticed you had a break in the build last night. Are you able to figure out what's going on? Well, I just got in and I'm going to try and reproduce the problem and nail it down. We'll have better information for you within an hour. Don't know, I'm trying to, no, repro, I can't reproduce it. And you're working on this for a while and trying to characterize it, but I can't even reproduce it. If I try throttling the network, then yeah, I can get an error, In fact, maybe I'll get an HTML control not found exception in that case too. But is the same HTML control? I don't know. And after a while of working on this, here comes your lead for the third time. He's anxious because we're close as shit. I mean, things are getting down to the wire. So, have you figured out what's going on yet? I can't reproduce it. I tried throttling the network, and I tried injecting the failure, but I'm not sure exactly what happened. Basically, I can't reproduce the error. So we're good to ship then? Yes, let's ship. And so, the moral is, don't drop those actionable bits on the floor. Because that's what's happening. In this situation, you'd love to go to the lab and do a Vulcan mind meld with your lab and say, okay, well, oh, this failed. What was happening, by the way? And what was going on in the code precompiled? What exactly was it doing with the product? And what was the product doing? And what was the network doing? And you want to know all this stuff, but you can't because that information is gone, and now I can't reproduce it. So this happens in the conventional patterns of automation, is that those actionable bits, actionable meaning they will tell you what to do and what's going on, basically. You drop them on the floor because that's the way it's done. That information is gone now. So I'm going to talk about testing and automation and MetaAutomation, how it relates to automation. Atomic check is the least dependent pattern of the language. And I have a diagram of the 5 patterns in the language, and atomic check is there. It's the least dependent. It's the most like an automated test automation in atomic check. So Glenford Myers, and I was just talking with him talking to Joe about him, The Art of Software Testing in 1979, so ancient history, but some of us were alive then, so. Testing is a process of executing a program with the intent of finding errors, bugs. And that's really what he means. I looked at his book and looked very carefully. Okay, he talks for a whole section in the chapter about this, and he basically says the same thing about 5 times. It's all about the bugs. It's about finding bugs, and there is nothing else. Don't worry about anything else. Just find the bugs. And I don't think he was talking about QA as if it were a separate entity. He was talking about good quality, as far as I could tell. And if you go out on the internet and search for that quote, you'll see it 10,000 times, 5,000 times without attribution, and that is the conventional wisdom that testing is about finding bugs. And Dr. Ken Kainer in 2004, a little more modern now, he's an educator at the Florida Institute of Technology, I think. And he said, well, he asked a question, he posed a question, the primary reason of testing is to find bugs. He basically says yes. So, and he has a long, convoluted answer to that question. He has 11 sub-reasons. Number 1 is find defects. Number 2, maximize bug count. You're seeing a trend here. Number 3 is about the ship, no ship decision. And then blah, blah, blah. Number 6 is assess conformance to specification. Now he's talking about, does this thing actually do what it's supposed to do? And number 10 is assess quality. And number 11 is verify correctness. So I am baffled, actually. I don't know why Kainer was being so cautious here, but he's still saying, yeah, it's about finding bugs and then you can assess quality. But mostly it's about finding bugs, and I don't know why he does this. I mean, this is what he's saying, basically. According to Scripture, because 1979, yeah, that's Scripture, find bugs, that's the first thing. And then decide when to ship. And then assess conformance about quality. I disagree. I think it's reversed. First, you have to assess quality, and finding bugs is just a part of that. It's a subset. You should never ship a software unless you have a really good idea of the quality. And this is, I'm talking about software that really matters, so not like Angry Birds. Well, you should have a complete understanding of quality, assess the quality. And finding bugs is just a part of that. It's an important piece, but it's not the whole thing. The bigger picture is assess conformance and quality. So the moral is, regression is at least as important as finding bugs. meaning that it's important to find bugs, but it's really important to know what worked yesterday still works today. Because if you're not verifying that, you're introducing a lot of risk, a lot of business risk in the product. Especially when if you were to just assume that the most important business behaviors of your product are still working, you could get a very nasty surprise after you ship. So that's about testing. Automated and manual testing are different, and I think they're fundamentally different. So introducing Otto the automaton, and this is my personification of automated testing. It's sort of like you have an extra team member, but it's not an actual person. Otto the automaton is all your test automation. So Otto is exceedingly good at moving bits around, making analytical decisions, working tirelessly, working quickly, and regressing some quality issues according to whatever you have automated. You run these automated tests, which I'll call checks, and I'll come back to that in a minute. And whatever you're verifying, well, Otto is really good at that, but you're only going to verify that you have automated. The other stuff you still don't know about. Because Otto is an idiot, and he's very bad at emotional decisions, which is really value judgments. Finding bugs, he's terrible at that. Perceiving obvious stuff that a person would see. And dribbling bits on the floor. And the asterisks, yeah, the laser pointer doesn't work on the screen. The asterisks here are really mean if you're doing automation well, and that's what MetaAutomation is about, is doing your automation effectively. Then you tend to dribble bits. Well, if you don't do it well, you tend to dribble bits on the floor. And finding bugs, automation done well is very important finding bugs. It's really mostly for regressing quality. But that's okay, it's still very important though. So introducing Tara the tester. Tara is our manual tester. She is very smart, and she excels at running test scripts, exploratory testing, finding bugs, perceiving and characterizing issues. So she enters bugs and tells what's going on in human-friendly language because she's human. And she's creative, resourceful, and knowledgeable. On the other hand, she's human. She has a life. She pulls salary healthcare, and she likes a challenge, but she gets bored sometimes. And she makes mistakes like we all do. So these are two entities on the team. Don't hire Otto to do Tara's job, because he won't do it well. Have them both do what they're good at. And if you can do that, have Otto do what Otto is good at, then you can have automation that's way beyond the functionality of what people are doing with conventional automation. It can be much more effective. More on that later at the talk. So here's a conventional software setup for our team. So here we have the system under test. I'm showing you the later. Okay, the guy with the chair is a tester. He's trying to get the product to do stuff. It's hard. It's hard to do. And then his lead, who needs information, updates, like what's going on with the product. Is our quality getting better? I don't know. Please interpret this for me. And so the lead, in order to get information about the product, has to talk directly to the guy who's running the automation, who wrote it, and he knows what the automation means because only he or she knows about that automation. Nobody else knows. And that's conventional automation. It's the way it's done. And the way I view conventional automation, and another way of looking at it, is that it is concerned with making the product do stuff, but less concerned with what exactly we're making the product do in the lab at 2 a.m. and what happens as a result. And that information tends to not be persisted, especially in the case of a pass. You get a green button or whatever, and that's all you get. That's conventional automation. I know other people are doing things a little bit differently. The problem is your lead gets frustrated, the lead of the person doing the automation, because he only has incomplete information, and sometimes whoever's making the automation, make the product do stuff, is not going to come out with all the information that the lead is looking for because, frankly, he doesn't have all the information. Or he said, well, I'm having trouble getting this running, but I don't really want to tell my lead that because that might look bad. Or I just don't know. Or if the lead asks, say, is this manual test, which you automated a month ago, is that covered or should we run it manually? I don't know. That's an important question to ask. It can be kind of frustrating because the lead and other teams don't get limited information with conventional automation. Well, with MetaAutomation, this is my dream, my labor of love. Basically, they have equal access to the product. They have equal access to, through an intranet site, for example, they have equal access to the quality information. When the automation runs happened, what the automation runs did, even the individual checks, which are called automated tests, and the steps, which ones passed, which ones failed, which ones were locked. And that is all available and equally to the lead and the person who wrote the automation in the first place. In theory, if you do this right, the person who wrote the automation won't know much that the lead doesn't know because they both have access to the same information and it can be communicated throughout the team. But that's MetaAutomation. It's about improving the, I wandered into it's about improving the flow of information and the fullness, the accuracy, and the precision of the information about what the product did and what happened as a result. So the meta of automation, MetaAutomation. Actually, I looked this up after committing to the name and I discovered that, well, meta is kind of like navel gazing, and I wish I'd known that earlier because that's not what I meant. The meta is like a higher level view, more abstract way of viewing what's going on. So here's one way of looking at that. Manual testing is where a person decides, well, pass, fail, or basically this is an acceptable behavior, or it's not. If it's not, I'm going to file a bug. Or if I find something that's wrong, buggable, or you might want to look at this, enter a bug that not get fixed, but you still would enter the bug. That's a person deciding that that's manual testing. Doesn't matter how many tools the person uses in addition to the system under test. The person decides pass, fail, basically, and that's a manual test. Because it's the person and the person's smart's working. With the automated test, you have the automation decide a pass, fail, criteria, according to some criteria. And then when you get the fail, the automation developer usually has to follow up to figure out, is there something to do here? Is there a bug or are there fixes to be made? And those of you who have done automation, you probably know that most of the time the automation failure is something to do with the automation itself. It's not a product quality issue. And that tends to filter up to the wider team. They think, oh, the automation is failing, it's their problem. They have to fix it. They have to fix the automation. This is with conventional automation. And MetaAutomation improves this drastically. But that's the conventional automation. And I've been in this situation. I've been there and worked in the trenches and done that. But as it's done conventionally, the person doing the test automation is going to get randomized. And it gets tiring. Meanwhile, the boss is saying something like, well, how many test cases did you automate this week? And how many more do we have to automate? And what percentage? And how long does it take to run the automation? And meanwhile, we have to write more automation and fix the existing stuff, which is time consuming. You have to reproduce the error. You have to step through. Sometimes you can't reproduce the error, or you have to try a bunch of times before the error will be reproduced because suddenly it's working and it looks like a false positive. The failure is a false positive. Very frustrating. But with MetaAutomation, there are no false negatives, meaning that if it passed, that means what we're measuring in the product really is an acceptable state. It really did pass. In fact, the check itself is self-documenting. You know what steps it does. And the code itself is, the steps are self-documenting. I don't have sample code for you because, well, actually, I have some samples of artifacts to show you a little later. So there are no false positives. We're not going to get failures when it's actually a failure in the automation rather than the product, or it's a failure because some external dependency is slow today, or there's a DOS attack on Yahoo, or something like that. And that actually is configurable because Alan Page at Microsoft had a very good criticism of an earlier version of one of my patterns called Smart Retry. And he was correct in that we don't always want to retry. Sometimes, anyway, that is configurable, and it's all the way up. The checks are, I should probably cover this now. So basically, if you have a test, is what a human does to assess something about the product. And generally you come up with pass or fail, but you can enter many other issues as well. A check is what I call, it's a kind of test. It is a subset of test. A check is where you're only doing one or a few specific verifications. And that's all you're doing. You're going through the steps and then doing one or a few specific verifications. And nothing else. And that's a check. This is what automation does well. Now Tara, the tester, she could run through a little scenario and she could enter $50 on just one little scenario, for example. Automation can't do that, not even close. You have to have specific verifications. And part of the atomic check pattern is to be very specific about those verifications, because really the target of every check is a specific piece of business behavior and nothing else. How to get there, verify the one or a verification cluster. My book talks about that too. So it runs faster and more robustly, and it's scalable. So now I can scale across resources because they're atomic and they're all independent of each other. And they're self-documenting, and I'll show you more about that a little later. And I'm getting ahead of myself a little bit. So on fail, though, the results are actionable because now you have very detailed artifacts. You have exactly what the steps are, because they're self-documenting now. You have your stack trace, you have any other data you want to put in there about what the product is doing. And you may want to have hooks, you may want to look at logs. You can put them in there because it's XML. You can put whatever you want in there. It's specific information and structured. And it's not a flight recorder log. And the communications are directed. And this is part of the pattern language where if you have strongly typed, structured information as a result of the check, now you can do a robust analysis because you can compare on a node of XML, I want to look at this element, I want to look at that attribute, but not that attribute. I want to look at the structure below this in my analysis and figuring out what's going on. And I can look at the different elements of the stack trace because I parse those out. And that's very simple to do. And now you have the information enough to tell you, well, if this were a real product bug, it looks like a product bug. And who's responsible? I'm going to send it to Patrick, because he's the guy who owns that part. So with MetaAutomation, actionable data from the system under test is captured, triaged, and dispatched. In other words, what the test devs would do to follow up on failures is automated as far as possible. And that's another way of looking at the meta. The meta of MetaAutomation is that lots of that stuff that is left to manual follow-up and manual communications and stuff, a lot of that stuff can be automated with configuration and choices and having strongly typed data from the artifact from the original test. So I warned you there's way too much information to cover in an hour, but any questions so far? All right. Patrick, shut up.
I was just counting up to that. Yeah, sorry.
Oh, yeah, it is a lot of stuff. It is a lot of stuff. Please do ask. I wish I had candy or something to throw at you guys with that. Anyway, back to Auto. Auto will be much more productive with atomic check. Remember I was talking about Auto and Terra, and Auto is your automation, and Terra is a manual tester. And she's smart. She may do other stuff too, but she is good at manual test and the whole quality picture, finding stuff. But Auto is not good at what Terra's good at. Auto is very good at atomic check, which is the least dependent pattern. And I'm sorry the text is so small, I'll read it to you. Atomic, meaning it cannot be made any smaller without changing its essential nature, i.e. testing the targeted behavior. And that's the atomic part of atomic check. And check is a test that is automated and repeatable with only a few specific verifications. Or I can say, or just one verification. And the repeatable part is very important because you can't do automated testing if it's not repeatable. Unless you're specifically trying to do fuzz testing or something. And then even then you need to know that you have enough data to repeat it if you need to. I have a diagram of the whole pattern language later on. So with atomic check, auto runs tests faster and more scalably. Because remember, atomic checks are, each one is independent of the other. None of them depends. There's no test chaining. There's no, the setup could be using the precondition pool pattern, which is the second pattern, if necessary, to make those run faster. But basically, if you have more resources, and if I gave you another VM, for example, you say, great, I can run my tests faster, I can run the checks faster. They're targeted, they're self-documenting, they're compact, strongly typed, detailed artifacts. The failures are actionable as they can be. If you get the right data in there, you can, check failed in a way that has never failed before in the lab last night at 2 a.m. But probably if you throw the data in there in a structured way, the data that's pertinent to the failure, you probably don't even have to reproduce it because you already have everything you need. You have enough information even to direct it to the person on your team who is an expert in that part of the product. Or if it's due to an external resource which is slow, you can do something else like log it, like, well, okay, Yahoo is slow again, for example, and so if we have enough of those logged events, maybe we should increase the timeout on that network connection. Or maybe we need to find another way, another service to ask, or another way to work around it. And that would follow the test infrastructure. But for the product, we can send it to somebody who knows. It won't fail on extraneous verifications. Smart retry is one of the patterns that I mentioned Alan Page in calling me out in that, well, sometimes you don't want to do that. But when you do want to do that, what you can do is eliminate really transient failures, what I would call it. It's like, well, it passed, and then it fails because something was slow. And you might not want to get a person involved in that case, in that sense. So basically save a lot of time. You can save the team all sorts of time. And the successes are noted. One thing about the atomic check pattern is that you always record an artifact. If a test is failing, even 100% of the time, you still have an artifact which records the steps and that it's succeeded. And so if you've been running this for the last 2 months, you still have all this data. The XML is very compact, and so you still have all that data. One thing about, Auto provides compact, detailed, strongly typed, and self-documenting records from the checks on the system under test. Mostly what people do in the conventional pattern is to have a log. And it's a flight recorder log, like, I did this, I did that, and it gets very verbose. And as Michael Corning would say, there's a very high entropy going on. A lot of the noise-to-signal ratio is way up there because there's a lot of stuff you don't care about. And plus, you don't want to store those for very long because they're actually not very useful. If you don't have a human to read through and parse it, because it's expensive to do that, you can't do much. And I've tried. I have tried to automatically parse logs, and it's sketchy. It's very difficult because the logs they're not structured. They're just linear. So, but anyway, Auto helps Terra be more productive, less error-prone, and less bored. And that was one of the promises on my first slide about helping the manual testers be more productive. If you have good descriptive information about the business behavior of your product, and by the way, as of this morning's build, or I can sync up my local workstation, this business logic feature, it's working. And this one is working, and this one is working, and they're all working because, and we know exactly what the verifications are. And if you know that this are all working, Terra doesn't have to worry about it. So for example, for a portal and a credit union, if we have atomic checks working on, let's check first, is the client getting the correct bank balance, right? Or if you go through a transfer from one account to the other, are the beginning and ending balances, are they all correct? And it is an example of business logic to be verified. So if Terra knows that, well, that's all correct, I don't have to verify it manually. Now this is different from conventional automation because with conventional automation, you have a manual test, like verify the transfer. And then you automate that, but if I am the lead, way back in that slide with the lead, the guy with the chair and the lead, and if all I know is that the test was automated and there's a pass, I'm skeptical of, well, what actually passed? I don't know what was verified. I mean, maybe it was the balance, but maybe you're looking at the wrong field or something. It's that the checks are self-documenting and they have the steps there. You can have a lot more confidence that this is being verified. Tara doesn't have to worry about it. She can concentrate on what she does well, and she'll have more fun at it too because she likes doing testing. She's good at it. So I have. Actually, I'm not sure how this will work in the second screen, but and I don't have a mouse. Almost there. Okay, so drag these over. I can't do that. Excuse me a second. I only have one USB port. This is a Surface Pro 3. So just one USB port. I'll use it for the mouse for a second. There we go. Okay, so these are examples of the artifacts. So I don't have a lot of pixels here, but this is an example of, this is a filled one. I guess I can't really make this much bigger because I don't have a lot of pixels, but this is an XML document that results from a failed atomic check. And so some things to note are when there is a style sheet defined, it's not applied here because I'm just looking at Visual Studio. There's a document and the root element is check run artifact because that's what it is. Here's some check run data. Check begin time, check job spec GUID. I use GUIDs a lot because they're globally unique in the context. And check method, check client name, and so on. And I'm going to scroll right. Basically, here's the values of the GUIDs. But that's just information about the check. And then we have another element here, check fail data, and that has the exception type. Oh, this is a sub-check exception. So there was, what I'm doing is actually this check runs across two different processes because I'm making an example of distributing the checks. And so I can't throw an exception across processes, but I can serialize it. And so that's what I do here. I get the sub-check exception, the exception type, the exception message, a stack trace. The elements of the stack trace. And here is the exception type in a stack trace. And this is the really cool part because the check steps are self-documenting now. So here's the name, so check one, top level step. There's step A, step C. And these are all, they don't mean much except they are specific labels to use. One cool thing about the check steps here is that they're not in a laundry list as you would have if it were a flight recorder. At St. Patrick, they're hierarchical, so you can have them in groups. Yes, David? You can have them in groups, and so they can, different steps are arranged as far as their importance, or they can be grouped, or if you know that the top level step includes both, step A includes step B. And this happens a lot, and I don't have a real world example. Well, actually, the other one is real world. But see that the checks are hierarchical. They're a lot easier to analyze that way. And the importance or scope of this step can be described because it's XML, it can be hierarchical. So this will show you the value of the steps. Okay, so the value is blocked because the step was blocked. Also, you have timing information, the time limit and the time elapsed. So the perf data is in line, and it goes into attributes of the elements about the different steps. Now you know how long each step took, and that gets persisted with the rest of the artifact. And so you can go back and do any kind of analysis you want. And so the perf data comes for free. Okay, well, this is a step that failed. So we had oops. So here we have, this step passed, and this one passed. This one fails. I have them cascading up. You don't have to do it this way, but basically, if yeah, you can. That's check failed, and these steps are blocked. The reason I know about blocked steps is because I kept a record of the previous run, and the previous run passed. And so I have, these are all the steps that happened. And now I'm expecting those steps again when I go through it a second time. And if the steps haven't changed, I have logic for that too. If the steps haven't changed, I say, okay, these are the steps. I'm running the same check again. And it fails here, and I don't know anything about these other steps except that I expected to do those steps. And so I'm going to call it blocked instead, because they are blocked, basically. Now the check as a whole is just a fail. Checks as a whole are never blocked because they're all the time. But this gives you detailed information on the steps in a hierarchy, and the target verification was here. It never happened. It was blocked. So that is failed sample. And here's a pass check. This is a different atomic check that I wrote. Basically, here's all your basic information. I'm going to make that bigger. Okay. Your basic information here, the check begin time, job spec GUID, job run GUID, method run GUID. Okay, send the email and verify receipt. And this is a check I use to, actually this is a test I have on my desktop to verify something about the website that I'm using for this. Does it send an email? So I load up a form and send it out. So this one is passed. So everything is passed, and it gives you the check steps about what it did. And so you're probably wondering, well, this is kind of hard to read. There's a lot of stuff here. It's XML. I like XML. Does everybody here know XML? Yeah, XML's great. W3C standard. If you can do XML, then do it. It's really cool because here I have the. Sorry, let me do this. There I have the documents in XML, but see this file here is a style sheet. It's XSL. So if I want to look at the sale check, you open up and I get HTML because you apply the style sheet, XSL apply to the XML, you'll get whatever you want, but I happen to create HTML. And here's my web page. So the result is failed. And here's that same data again. It's just presented. And here's an easier way to see what the steps are. So the reason I did XSL is to make it easier for myself to view, but also be an example of how cool XML is. One of the cool things that XML will do. And I actually wrote an XSD, also a schema, but I'm not using it here because I hadn't. Well, and in future, that's for future, I think, because it'll tell me about problems sooner than it would otherwise. So these steps are blocked, and then I got the exception information. And that's all just the presentation. Of course, you can write XSL, you can make the presentation any way you want. And then if we have a data of thousands of check runs, because these are fast, they run fast, and if you, as fast as possible, then if you have a data of thousands of them, you can do analysis on the XML, because the XML is strongly typed, name-value pairs in a hierarchy, and you can do all sorts of stuff. You can't do that with a regular model. So let me look at the other, here we go, the pass artifact. There we go. This is the one that passed, and this was a different check anyway. There's a sending email. So this is how it comes out looking. Everything's passed, everything's good. But that's just my style sheet. You don't have to do this with the data. But I do want to note how cool XML is because unlike logs, well, in logs, they're usually written by humans and intended for humans. Like if I make a log entry, and I know Patrick's going to see this at some point, so I write it in English, basically for Patrick consumption. But the problem is what I'm doing there is I have data and I have presentation, English grammar, and I mix them together. And that tends to make things verbose. And it also means you have fewer choices about presentation because it's already there. It's like a sentence or a sentence fragment. But with XML, you have pure data. And I can make the presentation separately. And I have my choice about presentations. And if I really want to get fancy with the XSL, I can make it look nice with the background, or I could just say, okay, I only want this part of the data. XML also works in databases, or at least I know it does in SQL Server, and you can store it there and access it and do all sorts of stuff with that. It's just an easier way of handling the data. So, back to,
Question.
yeah.
You may be getting to this, but you're collecting a lot of artifacts, and in order to do that, you have to write code to do that.
Mm-hmm.
You have some simple way of getting all these values and everything and pumping them into an XML format and writing them out.
Well, I have, that's a good question. The question is, what do you have to do to get all this data?
There's a follow-up question to that.
Right. Well, that's a great question. With the book, and there is a download of sample code. If you email me, I have cards here too. If you email me, I'll send you the link to that. You don't have to buy the book. I'm also working on a more sophisticated check that will, well, I'm making a lib, basically, that will be more useful. It will enable you to write checks that are distributed and will do all this stuff for you. So I'm trying to make it easy. It's still a sample implementation. I'm not sure that everybody will want to do it that way, but it will make it easy. It'll say, and by my sample code, it's in C#. The whole pattern is language independent and platform independent. I wrote it in C#. I've run it on a friend's Mac. It's platform independent. But really, it's just a sample implementation. You can write it in Java or C++ or whatever, but probably not Python. I don't know. But my book goes into that too.
I like the bottom line on the screen now. Faster than last time of 137,000 to 30,000.
Yeah, well, there's the format, milliseconds,
Yeah.
You can care about it. You could configure that. I think in XSL, you can even do little maths and things in the XSL, or have callouts to methods in the .NET framework if you want. I think that may be specific to the .NET framework and Microsoft's implementation of XML. But in any case, I don't use that stuff. So I'm going to try to find the mouse pointer. There. Go away. Go away. Okay, here we go. And, oh, one more step. This thing out. This is. Anybody have any more questions? That's not fair. I will have, in about a week, maybe I'm being optimistic because I could get interrupted. In about a week, I'm hoping to have the more sophisticated implementation of atomic check with placeholders for the next few patterns, but written in C#. And this will allow for distributed checks, and the stuff that is implementing atomic check will be its own separate lib. And so you'll be able to look and say, oh, this is how I implement an atomic check.
What do you mean by distributed check?
A check that is distributed across processes or virtual machines or networks. So it doesn't all have to be in the same process. In my first sample, it is all in one process, and that's how I wrote it. The challenge in having it distributed across processes, which I'd already addressed in one of these examples here, is you have to have a way of streaming data back and forth, probably over a text stream. And I do this with XML documents, serialized. And that's a challenge which I've addressed. I still have to do more testing and have a way to make it more distributable across machines. I have another test machine running now, but I have all other stuff going on, company meetings and things. But you'll have that opportunity. This will make it much more flexible to run automated checks, atomic checks, in the different settings, distributed. So gated check-ins, this is my dream. Basically, if we have a setting where you have multiple devs working on a product, and it could be a large number of devs, a product which it really matters, this is important to get the quality right. So you want to make sure that, say if I'm a dev and I write and I make a mistake or fail to take something into account, or for some reason a result of my change causes a break in the atomic checks. If you have gated check-ins, my submission is never going to make it to the repository. So Patrick's never going to see my code. This is good news because what he sees works and it'll still work. Now, with atomic check, I mean, these are design them to be fast, is simple, distributable, scalable across different resources because they're all independent of each other, as simple as possible, and focused on individual bits of business logic. And so they could be fast. And gated check-ins, well, all you need is hardware resources. And that's really cheap. I know it's hard to get a faster machine, but they're really cheap. So if you can do that, I mean, atomic check is ideal for doing gated check-ins. Now you have fast, scalable, repeatable, actionable results, and the quality can only get better because, as I'm working with Patrick, if I have a new feature, if it works, if I may implement a few new atomic checks in it, and I check it in, and if it all works, then what Patrick gets still works. Is if it fails, if I break something and check that in, Patrick might be down for a day. I'm just going to do email for a day and do a little web surfing and wait it out, and that impacts the whole team, not just Patrick, but everybody. But if the quality always gets better, then the risk is managed. It's cheaper for the team because nobody's interrupted, and the whole quality risk of the product is managed. We have a very good measure of the quality. We just have to implement more of the atomic checks. And in the sample code, I'm hoping to finish this in a week. It actually, to my mind, it's very simple to implement this given a certain library. And I had to make some compromises. It's not as simple than if I just have a line of code for each step. It's not that simple, but the return is significant. So if you have checks that are self-documenting and hierarchical, and they have perf data inline, all that kind of stuff. So this will be in the sample code that I have implemented. So given this, I think, is the atomic. I'll start again. MetaAutomation will enable gated check-ins. The quality is always getting better. So who benefits? Why would you do this? Well, people with experience making software automation, this is the way to do it better. People who love software, software quality, learning new and stronger techniques, and people who seek a deeper understanding. So I know this sounds like I'm just blowing my own horn, and I know that this is kind of hard to swallow for a lot of people because it's kind of radical, but I think it's inevitable because software is always becoming more important. In fact, pretty soon we're going to have self-driving cars out there on the roads, and we want the software to be good quality. We hope that the people who write that software had a good set of regression tests, right? So it doesn't matter even. It's now it's more than just our bank balances and how they manage their money in a credit union, but it's about more of the airplanes will be automated. You still need the pilots, but self-driving cars, medical devices, they already have a lot of software in them, and some people have died due to software buzz. So we can make this better. And SOX compliance. So in 2002, after Enron, remember Enron? Then we had the Sarbanes-Oxley Act in 2002, and it has another title, but I can't recite it off the top. So Sarbanes-Oxley is abbreviated SOX. So SOX compliance is how compliant is your company. It's mostly about financial stuff and honesty and openness and sort of reporting everything that's going on financially. But finances include a company's assets. For a software company, that means, the software you're developing. And does it work? Are you going to ship? Are you going to ship on time? Are people going to wait? And so quality is very important. As far as the managing risk part that MetaAutomation helps with, this will help with SOX compliance. And that's why I was brought on to Ubumoto, because I can do SOX compliance. Of course, they're about saving lives. Ubumoto is. And so they care a lot about quality as well. So MetaAutomation is a perfect fit for them. Plus, they're cool guys. So as far as who benefits, if you're writing the new Angry Birds, don't worry about it. You probably can't benefit. I mean, you could, but it probably doesn't matter that much to you. If your end user is a credit card number, it's a gouge card, maybe you don't care so much. Probably not so important. If you're doing sustained engineering, and this is my favorite graphic in the whole slideshow, two guys in a basically buggy or a bag. If you're doing sustained engineering, it's not the time to start afresh with MetaAutomation. But if you're starting a new product, this is a terrific time to consider doing it. A very different, new, and more powerful way of managing quality in the product. So people complain I still don't know what you're talking about. So what is MetaAutomation? It's a language of 5 patterns. I have a slide in the future. It enables much more effective automation for quality. It persists, organizes, and distributes information on what's going on with the system under test. And it's the next dimension of automating for quality. It's the meta. It's like now we're going to think about what exactly we're doing, what was the product doing at the point of failure. More than just a stack trace, but everything that was going on at the time. So here is, as I promised, here's the whole diagram of the pattern language. And this is on the back of my book, and it's also on my blog. I have a blog, metaautomation.blogspot.com. And I recently made some good entries. I'll mention those in a second. So these are the 5, should have my later, so it's absorbed by the screen. So atomic check is the least dependent pattern. That's closest to automating a test, is atomic check. Precondition pool is a way of making the checks run faster by saying, well, if you need a precondition, like you need a user that nobody else is using right now, or if you need a document, it'll set it up for you. And precondition pool would be run asynchronously. So it's out of process, and it basically has a library of what you need, when you need it, and here you go. And you can check it out until you're done. And when you're done, I'll recycle it if need to be. And that's precondition pool. It helps the checks run faster in more complex situations. Parallel run is running them in parallel and scaled with resources. So a lot of people are doing something similar, but atomic check makes it even more powerful. Smart retry is basically looking, have we seen this failure before? Just now, if I do it twice in a row, then okay, report that because I just reproduced the failure. If it's different, maybe I'll try a third time. And but if it's a transient error, I'll probably pass the second time. Don't alert anybody. Nobody needs to have their workflow interrupted at this point. I'm going to report and pass. The information about the failure, that's still persistent. And if somebody goes looking, they can look it up. But nobody gets interrupted. Automated triage is about figuring out automated. It's that automation part where you're automating what happens as much as possible. It decides who should be notified about this failure, or is this going to be reported to anybody at all? And so it's really kind of a triage. And it's not smart, but you can automate a huge amount about that. So I'm going to review and then we talk about my blog a bit. So we talked about testing. Regression is key in testing. It's important. Testing is not just about finding bugs. You have to do regression often to manage risk. Automation is not the same as manual testing. They're good at different things. And if you understand that, then you can do automation much better. Meta-automation is, say, keep, manage, and communicate important quality information. And I should say, make it accessible throughout the team. So you have it persisted, you can do analysis on it. Great for SOX compliance and many other things as well. Everybody will be happier. Atomic check is the least dependent pattern of the language. You have a question?
You know, I saw this on your earlier slide. I wanted to ask it then. What's number 3?
Number 3 is, it's virtual. I don't know. It's off in the other dimension.
All right.
It's behind the curtain. Big curtain. Did I repeat that? I did that before.
The first slide.
Yeah.
is number
2, 4. Thank you.
There's 3 kinds of people in the world. People who can count and people who can't.
Fair, thank you. Thanks, Patrick. Okay, how to get started? Oh, here's the last slide. My contact information. Thank you, Cordev. Cordev! Do the pizza here. And I wanted to talk about my blog, actually. I go on LinkedIn a lot. I spend a lot of time on LinkedIn discussions. There are groups there for testing and testing automation and that kind of stuff. And I have lots of discussions. And it's fun because on LinkedIn groups, I see, I talk to people, it's all around the world. Geography doesn't matter anymore. And we're talking about these different issues and how different people see things. It's very educational for me because these are people who are smart and they do their work well and they think about it differently than I do. And it's a way for me to check my understanding and communicate it. The other day, somebody challenged me. He said, well, I don't really know if meta-automation is innovative or not. And so this is not a flame war. He said that. He did not know, is MetaAutomation innovative? And he hadn't been to this talk. Oh, I wrote a blog entry about that. I think it was yesterday I posted. So if you go to my blog, you can see my entry if you're interested. Is MetaAutomation innovative? And yes, it is very innovative. And I also, because this last weekend I was meeting with folks at Ubimoto, we talked about SOX compliance. And I thought, well, this is great. What a powerful way to explain how this can improve investor value. So I made a blog entry about SOX compliance. And that is there also. If you go back to my blog, you'll see like different parts of ideas of my book. My book is not the sum of my blog's entries. It's not at all. The reason I wrote a book is because the idea is much too big for a blog entry, and it's too big for a magazine article. And it's 160 pages, but it's very dense, I think. And no, I'm sorry, 128 pages. It's very dense. It has lots of UML diagrams and stuff in it. It's very useful, and I brought a bunch, and $30 each, and I'll sign copies for anybody. And we went to raffle off.
Yeah.
We're ready for the raffle. Joe, you ready?
Yeah, for sure. In fact, we even have a copy of the book, and then they'll be available downstairs if you're interested. Okay, so tonight, 1 in 10 chance. Pretty good odds.
And
Honors go to the speaker.
And if you don't get a book tonight, you can always get one on Amazon.
This is random.
Coming up with what? Yeah, here we go. Oh, Andrew Bay. Is that it, right?
No, that's me.
Is that? Oh, did I pronounce your name?
Yeah, that's perfect.
Well, can I sign?
Yes, please. Sure.
Yeah. So thank you very much, man. And
Yeah.
it's great. And a really interesting concept. And what I think is so interesting is you took a year of your life to spell out this entire theory. I mean, imagine.
Yeah.
So you believe it?
Thank you.
Yeah.
I do. I have a passion for software quality. I want software to work, and I know perfect software is not possible. But I do have a passion, and I did write this down because I realized that my career is just not going to go anywhere because I'm more passionate about software quality than I am passionate about any of those companies I was working for. So to be honest, yeah, and.